I'm Anil Kumar, and in this video we'll learn a different technique to find equation of a quadratic function from the graph. So we have two questions here. The first one is find the equation of the parabola from the given graph, and the second part is determine the coordinates of vertex from your equation. Now, as you can see in this graph, the point of the vertex is not very easily to be found or read from the graph, but we will find the equation then calculate. Now, how to find equation of this parabola? We are given a point here which is at -2, 5. We can utilize this point also, but what is interesting is we'll actually utilize the y-intercept. Now, y-intercept is at -1. So this is the y-intercept at -1. So you'll also notice that we have a point which is symmetric to this y-intercept. We call that to be the image of y-intercept. So this point is called image of y-intercept. We'll use these 2 points to find equation, and that form is called partial factor form. So with this we'll also understand what is partial factoring and how to really utilize it. So we can write this in the form of an equation as y equals to a times x, and this value is at -5, so the factor will be x plus 5, and the y-intercept is -1, so we'll write like this. As you can see, if x is 0, then the value of y is -1, which is the y-intercept. If x is -5, then the first factor is 0. We get -1. That is the image of y-intercept, right? So that is how you get your equation. Now, to find the value of a, we can use the point given to us, which is -2, 5, right? So -2, 5 is a point. Let's call this as a point P, which we are going to utilize to find the value of a. So 5 equals to a times -2, x is -2 plus 5 -1. So let's find what a is. We'll bring 1 to this side, so it becomes 5 plus 1 equals to -2a times 3, and that gives us 6, and -2 times 3 is also 6, so -6, so -6a, and we can say a is -1, right? So we get a value of a as -1, correct? So we can write our equation as y equals to, since a is -1, minus x times x plus 5 -1. So that is a quadratic equation. If you multiply and expand, you get a quadratic equation. Do you get it? Okay, let's do it. So before going there, what I would like to do is I'll do the part 2 first, and then we'll expand and write it in standard form. Okay, part 2 is kind of interesting. Now you will notice that we have two symmetric points, and midway between them should be the axis, right? So what is the point midway between these 2 points? That is what we have to figure out, correct? So what we do is we find the axis of symmetry. Now, axis of symmetry will be at x equals to, this point is at 0 and this point is at -5. 0 plus -5 divided by 2, which is -2.5. So we have axis of symmetry here at -2.5. Okay, so let me draw this line here. This is at -2.5, and we know that the vertex will lie at this point, correct? So we can substitute here -2.5 and then find where the vertex should be, right? So let us do that part. So part 2, so you'll find y equals to, replace x with -2.5. Minus of -2.5 times -2.5 plus 5 -1, correct? So that gives us 2.5 times 2.5 -1. This is 2.5 times 2.5, 6.25, right? It is 6.25 5 minus 1, so you get 5.25 as your maximum. So this point here will be at minus 2.5 and the y value is 5.25. So that is how you can find the vertex, right? Now let us get back to the part of writing the equation in standard form, right? So you have this equation here. So what we will do is we'll just expand. So we get y equals to minus x squared minus 5x and minus 1. So simple, right? So we get our equation in standard form, which is clearly minus x squared minus 5x minus 1. So simple. Do you see that? So this equation can be written in the standard form also very easy, one step away. Do you see that? So that is a very effective way of finding equation of a parabola, especially when you don't have very many points to look for. And this is a very standard method called partial factoring. Right? We will in this playlist do few examples based on partial factoring, and slowly I think you'll appreciate it. I'm Anil Kumar. You can subscribe to my videos and learn. Thank you and all the best.